I make this video for my class EL6303, and here's the second question in my homework 11. And in this question, we need to distinguish whether this function could represent an autocorrelation function of WSS stochastic process or a spectral density function. Well, here, in the first one, this one, if IV is an autocorrelation function, obviously we could get the spectral density function here. This function, the autocorrelation function, this one obviously is non-negative, and this is non-negative as well. Second, if this function is a spectral density function, by calculating, we know that this is the autocorrelation function, and this is non-negative, and the spectral density function is this one, is this non-negative as well. So obviously, this could represent both the autocorrelation function and the spectral density function. Well, on the other hand, so later we're gonna move to the question B. In the question B, this is the second function. If f is an autocorrelation function, we could get that this is the spectral density function here. This is non-negative, and this is non-negative as well. So here, if this is a spectral density function, we could get the autocorrelation function. The autocorrelation function is this one. So obviously this is non-negative. So F could represent both. Well, here I move to the C. If FV is this one, if FV is autocorrelation function, we could get the spectral density function. But actually, the spectral density function here, we could not make sure that it is always non-negative. Actually, to some points for omega, it's okay to be negative. So here, it is not a non-negative function. And here, use the similar way to get the autocorrelation function here. This is non-negative as well. So the F could not represent both.